Now, in our previous video, we dealt with this vector component of unit vector in 2D. So we can see that according to the position vector here, that's OA, which is the position vector, has two components, A on the x-axis, B on the y-axis. And when we rewrite this in terms of unit vectors, we can say that OA is equals to AI plus BJ. Moving on, let's now consider what we have here. This is a 3D vector. Okay, we have a vector in space, so it has three components. We have the x-axis, we have the y-axis, and thereafter we have the z-axis. Now we can see the unit components here. On the x-axis we have I, on the y-axis we have j, and on the z-axis we have k. So this is the position OB. Now OB in this case now has the column vector of three components. On the x-axis we have A, on the y-axis we have B, and on the z-axis we have C. Now this is OB in a column vector. Now for us to rewrite OB to be in terms of unit vector, we can simply write it as AI, because I is a representation of the x-axis, plus BJ, because J is a representation of the y-axis, and finally plus CK, because K is a representation of unit vector on the z-axis. So now, if we have this, we are familiar with if R is equals to XY. We know that R can be written as XI plus YJ. Similarly, if R is equals to XYZ, we know that therefore that R is equals to XI plus YJ plus ZK. Now this is also the same if we change XYZ to R ABC. So if you say R is equals to AB, we know that R is also equals to AI plus BJ. And also if R is equals to ABC, we know that R is equals to AI plus BJ plus CK. Now we are familiar on how to calculate the magnitude of the column vector of two components. How about the magnitude of the column vector of three components? Now we know that R, the magnitude of R here is the square root of A squared plus B squared. However, the magnitude of R in this case is equals to the square root of A squared plus B squared plus C squared. Let's take an example. We're given that R is equals to the column vector of 1, 2, 3. Therefore, the magnitude of R in this case is equals to the square root of 1 squared plus 2 squared plus 3 squared. And this will give us the square root of 1 plus 4 plus 9. And this will give us root 14 units. Now, just as we are familiar that when we are writing R is equals to, let's say, 1, 2, we know now that R means we are writing 1 into 1, 0 plus 2 into 0, 1, where 0, 1 or 1, 0 is the column vector for I, representing I, and 0, 1 is the column vector representing J. Now what happens when we come into a vector in space? 1, 2, 3. Now when we come into vector in space, we will realize that the column vector in each case will change. Now in this case, we know that we will have that 1, 0, 0 will be the column vector representing I, 0, 1, 0 will be the column vector representing J, and 0, 0, 1 will be the column vector representing K. So we can rewrite R is equals to 1 to 3, so be equals to 1 1 0 0 plus 2 into 0 1 0 plus 3 into 0 0 1. And when we rewrite this, we have this to give us 1i plus 2j plus 3k, and this is R.